But also just wanted to note, this is the 10th year of the River Herring Forum since its inception in 2014. And just wanted to give everyone here a big round of applause for sustained interest in the conservation restoration of these species, and highlight that this is a great opportunity to share your work, to share things you've observed in your region, issues of concern, issues of hope that may bring hope to the audience, things like that. It's a great way for folks to get a sense of river herring management at a coastwide scale. It is an open forum as well, so feel free to spread the invitations for future meetings around, or share these recordings for folks who may be interested. And also, feel free to speak up during the open discussion and updates section at the end of the meeting. So I will note, James, I think this agenda, we had to strike Peter Daniel from Hofstra at the 3:05. I sent out an updated agenda, but he had a conflict and wasn't able to make it. So we have an extra 15 minutes for discussion at the end, or should. But anyway, that's it. And with that, we're going to jump right into our ASMC updates, and I'll pass it back to James, and then I'll be standing in for the New England Council updates at the end there.
Thanks. Yeah, I'll keep it quick. I know we have a lot to get through, and I'll show the updated agenda next time I can display it. But yeah, so ASMFC, the biggest thing obviously was at the summer meeting. The board reviewed and approved for management use the River Herring Benchmark Stock Assessment, which we are going to be talking about in our first agenda item today. I'm happy to have Dr. Conroy, the chair of the Stock Assessment Subcommittee for the commission, will be presenting that. And then the board met a couple weeks ago at the annual meeting in the fall, and there were several sustainable fishery management plan updates. So those are state specific. In Maine, Connecticut, or for American shad was Connecticut and Massachusetts, but then river herrings was in Maine and New Hampshire. So those updates are now on our website. I will put our species webpage for shad and river herring in the chat for people who want to go find those. And also I know we sent it out in the email, so you've all probably seen it, but I will also, on that same page at the bottom, you can find links to the full report for the stock assessment and the appendices. Other than that, if you'd like to see any more detailed presentations about what was in those sustainable fishery management plans, I can also place the link to the YouTube recording of those presentations from the meeting a couple weeks ago. With that, I'll pass it off to Jason Didden for the Mid-Atlantic Council update.
Can you still hear me?
Yep, sounds good.
Okay, cool. Yeah, I'll just flag a few things. One is at our December meeting, we'll get a presentation on the Manomet folks who were designing the kind of a portal to try to centralize river herring run information, and whether or not it becomes a widely used tool will kind of depend on folks' kind of judgment of its utility. But they took some work that they had done kind of focused in Maine and expanded that. So we'll get a presentation at the December council meeting on kind of like a centralized portal for run information. Other than that, I was just going to flag for our 2025 activities. We also have continuing the Inflation Reduction Act project that Janet and I is doing under contract for trying to extend some of the recent work on risk modeling for river herring bycatch, trying to extend it, maybe incorporate some observer data and try to make some of the resolution maybe a little bit finer scale in time and space to see if it could be kind of made into a practical tool. So that work will be ongoing through 2025 and into 2026. And then for other council tasks on the 2025 implementation plan, we'll get a new Atlantic mackerel assessment. So the council will set 26 and 27 specs with that. It's really just an incidental fishery for 24 and 25. So depending on how that goes, the council will then consider what kind of river herring and shad cap for any Atlantic mackerel fishery that might be feasible given the outcome of that assessment. As part of that, we do like a every other year river herring and shad update that just tries to summarize some bits of information that the council had previously requested to try to inform that cap. So we'll be doing that again, probably both of those will probably either our August or October meeting. And I think that's it for me.
Thanks, Jason. I think I'll work to get from you the link for that December council meeting in case folks are interested. I assume it's open to the public. Is that correct?
Yep.
Okay. I'm wondering if folks may be interested to hear an update on the Manomet effort. So that'd be great. Thanks for coming to speak on that today. If anyone has questions for Jason, feel free to answer them enter them in the box, in the questions box. But I'm not seeing any, so I'll just jump right into the New England Fisheries Management Council update. And the reason why I'm giving that update, not a council employee, but a NOAA Fisheries employee, is that Jamie Cornane is not able to make it, at least for the first part of this meeting today. And I'm just going to share two documents that she shared with me that she thought would be of interest to the forum. Just dropped one in the chat, which is the 2025 to 2027 Atlantic herring specifications with a request for in-season adjustment. And the things that I noted in this document were that and I may be butchering the process, but essentially what I understood was based on the latest stock assessment for Atlantic herring, the council recommended that the quota for the Atlantic herring fishery be significantly reduced to 2,710 metric tons, which is almost a 90% reduction in the quota. They go on to say in this document that, if it's approved by NOAA Fisheries, as expected, it'll be the lowest catch limit in the history of the Atlantic herring fishery management plan. And they also state that the catch limits will not support a directed commercial fishery for Atlantic herring. So that's a pretty marked change in that for that species. I will note though, they state, overfishing is currently not occurring in that document, but it is under a rebuilding plan, which is expected to be rebuilt by 2031. But they've noted low recruitment for those species. For this group, I'll note that the council agreed to maintain the current river herring and shad catch caps in the 2025 to 2027 specifications package. And I believe the reason for this, well, here, I'm going to drop the other link, which is the 2024 to 2028 research priorities. And as part of the Amendment 10 process for the Atlantic herring fishery, they received a lot of public comments. A lot of that comment focused on shad and river herring bycatch avoidance. And as a result, they have directed let's see, I'm not sure what group is exactly responsible. I think it's the herring plan development team needs to is to look into mechanisms to mitigate river herring shad bycatch in the Atlantic herring fishery, including time area closures and catch cap values that are reflective of regional river herring shad abundances that scale with ceilings and floors to match the Atlantic herring abundance. And then finally, the PDT will develop recommendations for implementing improvements to the accuracy and precision of river herring shad catch estimates. So my sense is, and I may be wrong in this, and Jamie could certainly weigh in on this when she calls in later, but my sense is that this effort will sort of precede any adjustment to the river herring shad bycatch cap. So essentially, they need to do the work to establish a new mechanism for specifying that cap before they're going to go about implementing it as part of the fisheries allocation. So anyway, with the full caveat that I did my best to summarize that based on the information provided to me, and I'm not a representative of the New England Council. Just wanted to provide those two documents and a little summary for folks here, just because I know that fishery in particular has been of interest to this group. And with that, we can take any questions on the council updates or the ASMFC updates, or we can roll right into Margaret's presentation. It looks like I'm not seeing any questions, so feel free to follow up with us after the meeting, and if Jamie's here, certainly can ask questions at the end. And then I'll just encourage those folks who are going to speak next. If you'd like to share your camera, you're certainly welcome to. I think it helps put a face to the name and keep it from being a disembodied voice. So thank you. And yeah, thanks, Margaret. Appreciate you coming to share the findings of the benchmark stock assessment today.
Hello, everybody. I'm going to be giving you the 2024 River Herring Benchmark Stock Assessment report here, and I'm sorry about the dog in the background. So this stock assessment is a product of the ASMFC River Herring SAS and the Shad and River Herring TC, whose members are noted here. So river herring, as you know, it's a data poor species, and it is still a data poor species this time. It's a data poor species complex, and it's challenging to assess, but we've made some progress since the 2012 benchmark. We have an improved understanding of the stock structure. We've added some new data sets, and this time we used abundance trends and/or mortality estimates for 84 rivers. That's representing 105 stocks of river herring. We have refined our methods for trend analysis and Z estimates, and we have some new modeling approaches. So we have a hierarchical growth model for each species. We have a stochastic SPR reference point model. We have a habitat model. And we did some work on data limited bycatch cap options. In this presentation, we will go through stock structure, then data, methods, stock status, bycatch caps, research recommendations, and then a summary of the peer review. Start with stock structure. Benchmark, we assessed river herring at the river level and then pooled up to state to summarize our trends and developed Z reference points at the coastwide level. But the SAS felt that using stock region to pool data and summarize trends was more biologically meaningful than state. So we assessed alewife and blueback herring at the river level wherever possible, and then used genetic stock regions to pool the data where necessary for reference points and to summarize trends. Our genetic stock regions are based on genetic work by Reed et al. 2018. Here we see the stock structure that we used. On the left is alewife, on the right blueback herring. You see for alewife we have 3 stock regions: northern New England, southern New England, and mid-Atlantic. While for blueback herring we have 5 stock regions: Canada, northern New England, for which we only used the US portion of that stock region, and then mid-New England, southern New England, mid-Atlantic, and southern Atlantic. So you'll see that some of the names are the same for both species, for instance, southern New England and mid-Atlantic, but the rivers included in them are not the same. And you can look all of that up in detail in the stock assessment report as to which rivers are in which. Let's move on to data. First, we'll talk about landings and bycatch, and then indices and run counts. Our total removals are presented as river herring removals because it's difficult to separate by species, especially for those historical landings. They are presented in both weight and numbers, which means there is some translation there. Commercial landings and bycatch in weight are converted to numbers. Recreational total catch in numbers is converted to weight. And we do those conversions based on the average size of river herring for each sector where sampling was available. This is our total removals in weight, and please keep in mind that historical removals are not comprehensive, and we certainly underestimate the removals, possibly by many multiples of what is shown, especially for those early ones. The You'll see that the total removals have declined significantly since the 1950s and 1960s. In the last 10 years, the total removals averaged about 2.67 million pounds, which is about 4% of the reported landings at the height of the directed fishery. Here's the total removal in numbers, and the overall pattern is similar for these removals in numbers. In the last 10 years, the total removals averaged about 6.83 million fish per year, which is approximately 4% of the average reported landings at the peak of the directed fishery. If we zoom in on the more recent years, we can see there hasn't been much of a trend in total removals since the mid-1990s. Note that the estimates of recreational catch start in 1982 in the pink, and the estimates of bycatch start in 1989 in green. The recreational removals have generally been small and have high PSEs, and the bycatch estimates make up a significant portion of the current removals. This is bycatch versus directed fisheries. This is proportion of river herring removals, and we can see that bycatch has been about 30 to 75% of removals since 1989, but it was estimated as being much lower than average from 2020 to 2022. So let's look at that recent change. So looking at 2005 to 2019, I'm going to call that the early period here, and then 2020 to 2022, that's the recent period. We see that the estimates of bycatch for 2020 to 2022 were lower than in previous years and made up a smaller percentage of the overall removals. So for instance, in the early period, the bycatch was about 757,000 pounds per year, whereas in the more recent period, only 200,000 pounds per year. That was 2.81 million fish in that earlier period versus only 0.75 million fish in the more recent period. The bycatch went from 27% of total removals in weight down to 7.5% in that more recent period. And then it went from 35% of total removals in numbers down to 10% of total removals in numbers. And that could be due to the lower effort in Atlantic herring and mackerel fleas in recent years, but there has also been lower observer coverage and port sampling in those years, especially in the Mid-Atlantic midwater trawls. So you may have noticed that bycatch makes up a higher proportion of total removals by numbers because the average size of the river herring in the bycatch is smaller than the river herring in the in-river fisheries. Length information collected by the observers shows that the ocean bycatch, that's the bottom panel here, contains small river herring, defined here as less than 200 millimeters, that aren't seen in the in-river monitoring, which indicates that the ocean fisheries are catching juvenile and immature river herring as well as these mature adults. So moving on from removals to run counts and indices, the TC reviewed a wide range of state, federal, and academic data sets. A run count or survey was used in the trend analysis if it had 10 or more years of data, if it had consistent methodology or changes in the methods were accounted for, and if it encountered river herring in at least 10% of the tows or hauls, etc., over that time series. Some surveys or run counts with less than 10 years of data were accepted for use in the next assessment update. So for alewife, there were 52 data sets for trend analysis, made up of 23 run counts, 10 adult in-river surveys, 11 recruitment surveys, and 8 ocean mixed stock surveys. For blueback herring, there were 42 data sets for trend analysis, 10 run counts, 13 adult in-river surveys, 12 recruitment surveys, and 7 ocean or mixed stock surveys. We also had 14 run counts that were not separated to species. SAS assumed that run counts were more like indices than true population counts. They represent trends in abundance, but other factors like passage rates, amount of spawning habitat below the location of the count, environmental factors, et cetera, mean we don't know how much of the spawning population is actually being counted. Now, these data sets, these different types of data sets, are not distributed equally across the coast. Here we have some graphics showing you alewife on the left, blueback herring on the right, and where these are. So the run counts are shown either as yellow circles if they're species-specific run counts, or asterisks if they are combined species. The adult fishery independent surveys are the blue squares, and the young of year or juvenile indices are the pink triangles. And so we see that most of the run counts are in the northern regions, and most of the surveys are in the mid-Atlantic region. And the South Atlantic region for blueback herring is particularly data poor. Moving on to methods, we'll talk about trend analysis, Z comparisons to reference points, and then our habitat model. For trend analysis, we looked at a few things. We looked at Mann-Kendall trends, which detect an increasing or decreasing trend over the time series. We looked at autoregressive integrated moving average, which minimizes your measurement error and decreases variance. We looked at the probability that the terminal year of the ARIMA is greater than the reference year of 2009 or greater than the 25th percentile of the time series. We used 2009, which was the year that Amendment 2 was adopted for river herring, as the reference year to try to address the question of whether river herring abundance has changed since management action was taken. And we applied this trend analysis to run counts, indices, and life history characteristics, including mean length, percent repeat spawners, etc. So we found for the life history trend analysis that there were very few significant trends. That was looking at maximum age, mean length at age, and percent repeat spawners. And for the trends that we saw, there was some difficulty in interpreting these. For example, does a declining repeat spawner percent indicate decreasing survival on older fish, or higher recruitment and more first-time spawners? So it's hard to tell without other data on recruitment or abundance. So because of these difficulties, the TC-SAS did not rely on these results for status information, but you can see them all listed in the assessment report. So looked at total mortality in addition to trend. So what we did is we estimated Z, or mortality, from age data from in-river monitoring using the Poisson GLM method. We used the age of full maturity as the age of full selectivity, which was age 5 for most of the stock regions. We only applied this for years with at least 30 samples of at least 3 fully selected ages. And we calculated a stochastic Z 40% SPR reference point. So instead of using point estimates for the inputs like natural mortality, maturity, etc., we drew from a distribution of parameters to create a distribution of Z40 SPR estimates. And we developed reference points for each stock region. Probability of Z being above the Z40 SPR incorporates uncertainty from both the Z estimate and the reference point. Total mortality is based on adult-only mortality with no influence of juvenile mortality to the lack of data. In addition to the trend and the mortality, we also developed a habitat model. And it's a simulation model to look at the effects of habitat loss on the productivity of alewife and blueback herring in each stock region. So it's very similar to the model that was used for American shad during the 2020 benchmark, but the life history information and habitat data were updated to reflect alewife and blueback herring stock regions. The results are summarized coastwide and by stock region in this presentation, but you can look at table 28 and table 39 in the full assessment report for a river by river summary of stock status. Those tables indicate for each river the Mann-Kendall trend over the entire time series and the Mann-Kendall trend since 2009. the probability of the latest year of the ARIMA being above the 25th percentile, and the probability of it being above the index as of 2009, and the probability of Z being above the Z40 SPR reference point in the most recent year. Let's move on to stock status. We'll talk about that first, the habitat model, then the Mann-Kendall trends, then the ARIMA comparison to reference, and finally total mortality comparison to reference. There were some stock status challenges. So river herring abundance is affected by a number of factors: directed fishing, of course, bycatch, habitat loss and degradation, and passage mortality, and environmental factors, including predation and climate change. Each river system has its own challenges, and for almost all stocks, we have only one data source. All of our data sets on abundance and mortality start well after the peak of the directed fishery in the 1960s and the collapse of the landings in the 1970s. So first, the habitat model. Here, we've switched these for habitat model. Blueback herrings on the left and alewife is on the right. A significant amount of river herring spawning habitats been lost or made difficult to access due to dams. Here we see the order of the dams, and so darker redder colors here indicate river herring have more barriers to accessing that habitat. For example, to access those darkest red habitats, the river herring would have to cross upwards of a dozen dams. And here we see 3 different scenarios and the coast-wide alewife abundance in millions of fish that goes along with each of these scenarios. This is showing the loss of access to spawning habitat, how that results in lower potential abundance. So the historical abundance of spawning alewife was predicted to be about 352 million fish under the no dam scenario, that's on the right. The abundance under the no passage scenario was 87 million spawning fish, which is a reduction of about 75% that corresponds directly to reductions in habitat, and that's on the left. And that middle point is the current level, and the current levels of passage don't provide much improvement over the no passage scenario. Similarly, for blueback herring, we see this chart here. The mean historical abundance of blueback herring was predicted to be about 63 million spawning fish under the no dam scenario. Abundance under the no passage scenario was about 41 million spawning fish, which is a reduction of about 35%. And the current levels of passage again don't provide much improvement over the no passage scenario. So from our habitat model, our stock status shows that alewife and blueback herring are depleted relative to historic levels. The habitat model indicates the overall productivity of the stock is lower now than it was for an unexploited population in an unaltered landscape, but it does not currently incorporate fishing mortality, so it doesn't provide an estimate of true current abundance. Let's move on to our trends. So this is a graphic of our full time series trends. We're looking at whether they are increasing or decreasing and where those are along the coast, with alewife on the left, blueback herring in the middle, and undifferentiated river herring on the right. So the trends are shown with a downward pointing red arrow if they're decreasing, and the upward pointing red triangle if they're increasing. And if there's no significant trend, there's a black square. So we can see there's no clear coastwide trends. The more northern regions seem to have more positive trends, but even within the regions, there's differences from river to river. And then also remember that this fish passage trends, and most of those are in the more northern areas, are influenced by passage efficiency and counting efficiency, in addition to population abundance changes. So these are the full time series trends. So they vary, the time series length varies with whatever we could get. We show just the trends since 2009. From 2009 forward, we see there's few significant trends. There's 2 increasing trends for each of alewife, blueback, and river herring, and there's a decreasing trend for blueback herring. So the alewife increasing trends, you see those on the Damariscotta River run count, the Merrymeeting Bay Young of Year Index, and those are both in northern New England. For blueback, we see a decreasing trend in the Santee Cooper River, South Atlantic, and increasing trends in the Merrymeeting Bay Young of Year Index in the Canada, northern New England, and in the Albemarle Sound Adults Index. Here we show the ARIMA results compared to the 2009 reference year. So are we doing better than, what's the probability of the most recent year of the index being above that 2009 value? The shape indicates the type of data, whether it's a survey or a run count. So the run counts that are species specific are circles, run counts that are combined species are diamonds, and then the adult fishery independent surveys are squares, and the young of year or juvenile ones are triangles. As for color here, the darker blue indicates a higher probability, and the darker red indicates a lower probability, with lighter colors indicating about a 50% probability of being above that 2009 value. You can see that the northern points tend to be darker, and there's more light colored and redder symbols on the map in southern New England, indicating more lower probabilities. For total mortality, this shows along our map again, the probability of the most recent Z estimate being above the Z reference point. So here, red is a higher probability, blue is lower. So shape again indicates type of data. Darker red indicates higher probability, and that's of being above the Z 40% SPR reference point. So we see that most rivers had a higher than 50% chance of total mortality being above the reference point, with the more northern regions having a higher probability of being above the reference point. So we see something that may look a little contradicting, right? We're seeing increasing trends, but also high Z's in those more northern areas. And so we did take a look at that. And out of 105 stocks for which we have data, we only had 26 that had both Z and adult abundance trends. Made it a little hard to draw conclusions about this, but there is a whole section in the assessment report if you want details on that. So trying to draw all this together, our stock status for alewife here. On the left, we're looking at the time series trends since 2009. In the middle, we're looking at the probability of terminal year being, well, the number of data sets with a 50% probability of the terminal year being greater than the 2009 value in the middle, and a number of rivers with a greater than 50% probability of Z being above that Z 40 SPR on the right. So we see there's no clear coastwide trends since Amendment 2. There's very few significant trends. Those that are significant are positive. That high values are better for that middle column, that's the ARIMA column, and high values are worse for that right-hand column, the Z values. So the more northern regions seem to have more positive trends, but also higher Z estimates. Even within regions, though, there's differences from river to river in terms of trends and Z estimates. So if you have a particular river in mind, look it up specifically. Same stock status for blueback herring. Similar to the alewife, there's no clear coastwide trends, and while the more northern regions seem to have more positive trends, they also have higher Z estimates. Again, within regions, there's differences from river to river in terms of the trends and the Z estimates. There were no species-specific run counts or indices for the southern New England region for blueback herring, only the mixed species run counts, so that's why that one's blank. So in summary, there's no clear coastwide trend since Amendment 2. Some systems are showing positive trends, some negative, but many have no detectable trends. Northern regions seem to have more positive trends, but a lot of variability even within the regions. And the run count increasing trends may be influenced by increasing passage efficiency. Other regions have put a lot of effort into habitat restoration and dam removal, but so have states further south, and these states further south have not seen the same positive trends in run counts and indices. The northern New England stock region also counts for the majority of the directed catch in the recent years, while the states in the mid-New England, southern New England, and the Atlantic stock regions have closed their fisheries. So what other factors are affecting river herring abundance? There's a bycatch influence, and Reed et al. In 2022 looked at the genetic composition of ocean bycatch from the Cape Cod, Long Island Sound, New Jersey area, which has historically had high fishing effort and high estimates of river herring bycatch. This area, the majority of alewife bycatch was from southern New England stock region, and the majority of the blueback herring bycatch was from the Mid-Atlantic stock region. These are two stock regions that have had more negative trends in recent years despite habitat restoration efforts and directed fishery closures. So moving on to bycatch caps from here. Concerns about the impacts of ocean bycatch led to the board to include a term of reference to develop methods to calculate a biologically based cap or a limit on bycatch of river herring in the ocean fisheries. During the assessment, we did a proof of concept approach. We developed this using data limited methods to set bycatch caps based on trends in alewife and blueback herring abundance. We used the I-smooth and I-slope methods. These were peer-reviewed through the SAW-SAIC in the 2020 Index-Based Methods and Control Rules Research Track Assessment. And these two in particular had the highest median catch among the methods that achieved variability more than 50% of the time. Smooth and I-slope are conceptually very similar. The slope of the index in recent years is used to develop a multiplier that's applied to the recent catch with or without additional buffers. And if the index is decreasing, the bycatch cap would decrease. If the index increases, the cap would increase. The data that we used for these was the Northeast Fisheries Science Center species-specific coastwide bycatch estimates for our catch data. And then for our index data, we had the ocean mixed stock indices of the Northeast Fisheries Science Center bottom trawl and the NEMAP. And then for run counts, for alewife, we used the sum of the southern New England run counts, and for blueback herring, the sum of the Mid-Atlantic run counts, because these were the stock regions that comprised most of the bycatch in Reed et al. 2022. Of course, bear in mind that is a snapshot. So the final numbers of these index-based bycatch caps depended on the method, the choice of the index, and what kind of buffers are applied. We did some samples, and our examples, all the cap estimates were lower than the current bycatch caps. They were lower than the coastwide bycatch estimates, but they were higher than the recent estimates of catch against the current caps, because not all the coastwide bycatch of river herring counts against the current caps. So this index-based bycatch cap has some pros and cons. Pros, it's more biologically based on the current historical average approach. You know, as your indices decline, the caps will decline. If the indices go up, the caps can go up. But the cons are it's based on index data only. It's not a population model. It assumes that there's a relationship between bycatch and population abundance, although we know that bycatch is only one factor affecting river herring abundance. Work and consultation with managers on the scope and implementation. So our development was species specific, and the current caps are shad and river herring combined. Caps that we came up with as examples are coastwide, and the current caps are based on specific fisheries and gear area combinations. The data limited methods need more management input on risk and buffer levels, and then monitoring at a biologically meaningful scale is difficult. Not all bycatch affects all rivers and stock regions equally, and the current monitoring doesn't include genetics. So as an alternative approach, the TC staff strongly supported the species distribution modeling approach as either an alternative or complement to catch caps. That would be to model river herring distributions and identify potential hotspots where the risk of bycatch is increased, and use time area closures to minimize bycatch instead of an in-season cap approach. And this would avoid some of the issues with the intensive monitoring needs of the catch cap, but you'd have to develop those models further. Research recommendations. So the high priority short-term research recommendation for the assessment methodology is continued development of a habitat model or some similar model to predict the potential impacts of climate change on river herring distribution and stock persistence, and develop targets for rivers that are undergoing restoration. High priority short-term recommendations for research and data collection include developing consistent aging protocol across all states, establishing a database of existing data sources with comprehensive metadata and recommendations for use, expanding observer and port sampling coverage, including genetic sampling to better quantify incidental catch of river herring, studies to quantify, improve, and implement standard practices for fish passage efficiency, and evaluate and validate hydroacoustic methods to quantify river herring spawning run numbers in major river systems. That was it. So let's move on to what the peer reviewers have to say about this assessment. So the peer review, the review workshop for the assessment was conducted in June, and it focused on all aspects of the assessment, including the data, methods, and overall judgment of assessment quality for management use. So in the previous part of the presentation, that was just the overview of the stock assessment. In this next section, it'll highlight the peer review panel's conclusions and recommendations, and further details are provided in the review report. The scientific review panel was made up of 3 members, a chair, plus 2 additional technical reviewers. They had expertise in analogous fish ecology and population dynamics, stock assessment modeling, data limited methods, fish passage, and bycatch estimation. Dr. Adrienne Jordan was the chair from the University of Massachusetts. We also had Dr. Heather Bowlby from Fisheries and Ocean Canada and Dr. John Weidman from Rutgers. The overall findings are that river herring stocks remain depleted from a coastwide perspective within a decade or more of effort in restoration and moratorium, not leading to improved status. Most of the population trends were flat, although high variability resulted in a low power to detect trends. No official statement was made regarding current rates of mortality. However, total mortality is high in the stocks. Marine mortality is high, and there's a lack of data to determine the cause. Concerns over the potential for high levels of discard mortality and the current lack of monitoring. There's new habitat-based models, and that's showing promise, and it indicates lower productivity due to dams and habitat loss, and they encourage continued development of that. Based on the current methodology, analysis, and interpretation of results, they found that the assessment provides the best available science. Anyone have questions?
Great, thank you for that summary, Margaret, and really appreciate you coming today to provide this update to the group. I know folks may have seen a similar presentation before, but it's good to have you come and present to this group. We did have one question in the chat from Jason Didden, and this was near the beginning of your presentation, I believe. But
oh, sorry. My screen covered, the presentation covered up the chat, so I couldn't see it.
Oh, all good. It was just a question about the, I think the low reported bycatch numbers in recent years. The recent change slide, would the reduced coverage cause lower estimation or just more uncertain variable estimates of bycatch in recent years?
Well, it's more uncertain, so yeah. I mean, because obviously we scale it up, but if it's scaled up based on very few observations, yeah, it's very hard to figure out. But yeah, it wouldn't necessarily be biased downward. It's just super uncertain.
Okay. I'll encourage folks to raise hands, or I can keep reading off the questions box. It looked like Matt Ogburn added one that I was actually just just about to ask about the habitat maps and the habitat model, specifically about the blueback herring distribution. And I'm you know, it looks like, from my understanding, I believe that those distributions were based off of the USGS maps of historical occurrence, but it was just interesting that alewife were indicated, you know, going way up the Susquehanna, whereas blueback herring were not in that map. And I guess to further expand on Matt's question, I'm wondering what bearing that may have had on the productivity estimate for blueback herring and those differences we saw between blueback herring and alewife.
That may have something to do with the fact that the blueback herring didn't drop as far as alewife in terms of that lower potential abundance. As far as the map, so we, and you know, I'm speaking for the people that did the habitat mapping. I don't know if any of them are on this call, so if they are, they can speak up. But yeah, they started with the USGS maps, and then there was some historical knowledge of how far up the rivers the each species went, but a lot of it was given to the TC members who like opined on that information. And specifically for Pennsylvania, I don't really know how that went, but each TC member of each state would look at their own maps. Being from Delaware, ours was pretty easy, so I didn't really get into too much of what the other state members, they were dealing directly with the habitat modeling team themselves. So I can't speak directly to what happened with the Susquehanna and why it was thought or known that the alewife went further up.
Right. Yeah, just to follow on, I think the historical accounts mentioned specifically, you know, shad and alewife going up to, I think it was Cooperstown, New York was maybe the historical distribution, but I don't know that it was called out, you know, blueback herring were called out specifically in that sort of the main historical account, the one that's cited in the Susquehanna River Natural Fish Restoration Plan. So I'm wondering if that's why that was established, but certainly, you know, Matt or others, if you have, you know, other information, I guess it would be interesting to see if the model were run with those, you know, with the Susquehanna River production potential included for blueback herring, to see the sensitivity of that model to that particular watershed. But certainly, yeah, Matt, you have your hand raised. Certainly feel free to chime in.
Yeah, I don't have a specific data source to provide to that, because I imagine there just might not be much. But just based on what we've been finding about how far blueback herring go up some of the other systems, like on the western shore of Chesapeake Bay, for example, yeah, I'm just surprised they wouldn't go up, maybe not as far as alewife, but through much of those rivers. And so, yeah, I think your idea of doing a sensitivity analysis of that would be a nice way to kind of capture that, just to make sure that it's not a, you know, a huge change in what the coastwide population model might suggest.
Yeah, I can catch up with Dan Stitch and that modeling group and figure that out. Yeah, I know it's hard because the historical accounts often don't differentiate. Yeah, I don't know how to do that. Good question.
I'm not seeing anything more in the questions box. We, in anticipation of potential, group discussion, we set aside a good bit of time for this meeting agenda item. So, certainly folks feel free to raise your hands if you have comments on recommendations or other questions. I see Jason. Nope, maybe not.
Yeah.
Feel free to raise your hand. Oh yeah, go ahead.
A quick question on the index adjusting for the caps. You see, you could potentially get a situation where the index goes up, but the caps go down. Like if a cap was 50 and catch was 25, but the index went up 10%, the new cap would be like 27.5. Like, right, like the base that they would be adjusting from is catch, not cap. Is that right? That they were suggesting?
So, I mean, that's really something that we would have to talk to the managers about, because you could set it up either way, right? It could be set up however you want, and it could be set up with or without buffers. So that's like a management issue, not really necessarily directly a science issue. So that is why we said we developed these proof of concept. Like you probably could do something like this, but in terms of actually coming up with caps, like I said, we did some sensitivity analysis and tried different numbers, but those are not, like those have not been decided on by management. So you could do it either way. But yes, I do think that some of them do go from catch, which could be problematic if, like the example you gave, you're way under the cap.
Okay, thanks.
Matt Ogburn, is your hand a relic hand, or is it? Do you have another question? Nope. I see it went down. Ben Eberline requested showing the final slide again, the peer review findings slide. If you could pull that up, Margaret, that'd be great.
So what are you guys seeing? Because I can't tell.
we can see like
the slides, but not as a slideshow.
Correct.
Okay, that's fine. Because to do it as a slideshow, it covers up everything else for me. So.
Right. No, this is fine unless folks need it blown up.
Looking at so this one with the overall findings of the review panel, is that the one he's talking about?
That's it, he said. Not sure if he had any follow-up questions on that, or if it was just to get a sense of what the findings were. Jason, I see you raise your hand again. Please go ahead. Nope.
Yep, I'll just flag one of the, it was, I think under potential additions, I'm just scrolling down to make sure. So standardized bycatch reporting methodology is how NOAA Fisheries allocates observers. It has typically resulted in low levels of coverage for midwater trawl in recent years based on the formula. And it was, so one of the things that we're pondering is, could we amend the standardized bycatch reporting methodology to still to prioritize midwater trawl in a standardized fashion. In the past, NMFS was kind of ad hoc adding to observer coverage of that because of concern about river herring, shad, and other species. But with kind of the lawsuit and saying it has to be more standardized, and the solution to that to make it really rigid, they kind of lost the ability to do that. So it's kind of some very preliminary discussions of like, could you just make higher coverage of midwater trawl be standardized? Now it's a joint omnibus action to amend SBRM, so you kind of have to get the two councils and the service kind of all on board to pursue that. So it's on our possible additions kind of list, which is where kind of you know, things that we don't seem like we have the resources to address in the current year necessarily kind of live in that possible additions list. But I just thought I'd flag it as a thing that started to get a little bit of discussion recently.
Yeah, thanks for that update. Any questions around that from anyone? Feel free to raise your hand. Okay. Oh, Kevin, Job, go ahead.
Kevin, you're unmuted. It looks like on both ends.
Yeah, I can't hear you, Kevin, but it does appear that you're unmuted.
Yeah, Kevin, we're not here. You unmuted and then there's no sound coming out. If you want, you can type it in the questions box. Maybe there's just an issue, or try reconnecting the audio or in the audio tab.
Sorry about that. Did I see another hand? James, I had a question for you, or maybe for Margaret. You know, I know that in the last couple of stock assessments for river herring, you know, standardized aging methodologies has been noted as a repeated need. What's being done to address that need that's been identified for a while now? And are there any ideas to address it? It is a topic which I'm admittedly sort of ignorant of, but I know it has been noted as a need, and if it would improve future stock assessments, I'm wondering if it's an area of action. Do either of you guys want to weigh in on that?
We actually had long talks about about aging. So I do believe there's talk of having some more workshops, but there was talk that because the rivers are so different and each stock, you know, is in its own river, sometimes the aging is done slightly differently river to river, but it's because that is what shows the best outcome for that particular river. So I don't age them directly, so I don't know if I would portray it well enough, but there were, you know, examples of what, you know, how and why it varied from river to river. And so that was kind of a difficulty in trying to then standardize. So I know they did have an aging workshop a while back before I was part of this. So they did work on the standardization, but I know that that was something that would seem to be more of a difficulty for river herring than other species. James remembers more of that discussion.
Yeah, I don't
So
really
we
have much to add because there isn't really any momentum right now at the TC level to make it more of a requirement, try to move states in a particular direction. So yeah, there's not really that effort going on right now to try to force the hand.
Is another aging workshop what's needed? Or, I mean, I guess I'm curious, and I can't recall if that is published anywhere, but was there any improvement, I guess, following the last aging workshop? And, is that the issue, or is it more of a, what's needed? And I guess it's certainly a good discussion for this group, just given our coast-wide sort of representation.
That's a really good question. I'd have to check back on that. I don't recall the findings of that workshop. That might have been before I was here. I'm not sure. I'll look into it. I can follow up.
Okay. It looks like Kevin was able to get his question in the questions box. He had a question for Jason. Has there been any discussion about moving towards portside sampling for that fleet, the Midwater Trough fleet, to reduce cost? He imagines they already have video on board to prevent things like net slippage already, so maybe that would address the need for at-sea sampling. Has there been any discussion of changing methods there, Jason, that you're aware of? Or let's see, I'm wondering if Jamie is on. Doesn't look like she came on yet, but yeah, Jason, if you've got anything to add, that'd be great.
I mean, that was a shift, and I will try to get an update from NIMS on kind of how that evolved and what the current status of it is. I mean, I think it's and that could be part of like a change to SBRM, right? To require that instead of instead of the at-sea. So I think if the councils, when we're interested in opening up SBRM, it's a zero-sum thing. If something is getting more coverage, other fisheries are going to get less coverage. But so that was a hot topic for a while, and I'll do some follow-up with Jamie and/or NIMS to kind of see what the status of that is.
Yeah, and any of my NIMS colleagues who are in sustainable fisheries, I don't know if they have any insights on that, but feel free to raise hand and give an update to the group. Certainly would be interested to hear it.
Thank you, James and Jonathan, for the opportunity to present today. This research project is a collaborative effort between Cornell University, the New York State Department of Environmental Conservation, the U.S. Geological Survey, the National Marine Fisheries Service, and also the Frederick Mieser Laboratory of the Max Planck Society. And so before I move on, I'd like to acknowledge my co-authors here, particularly Maluska Hyde, who will be doing a co-presentation with me, and she'll be talking about the Alocene Tissue Repository at the end of this talk. Here I go. Okay, so this research was initiated to address a number of research priorities and knowledge gaps that were identified in the 2020 American Shad Benchmark Stock Assessment. Particularly, it was stated there was an interest to use single nucleotide polymorphisms to generate next generation sequencing data to resolve population genetic structure. It was also stated that it is important that we quantify stock composition of known bycatch and mixed stock fisheries operating in the Atlantic coast at the individual rivulet level. And if this is accomplished, we would then be able to evaluate coastal bycatch and mixed stock fisheries on the depleted shad stock. And for this project, we give particular attention to the Hudson River. One of the major limitations to moving forward with these objectives was the lack of ability to resolve population genetic structure to date. The most comprehensive assessment was previously conducted by Hasselman et al. In 2013. They surveyed 33 populations and 12 microsatellite loci and identified 9 genetic regions throughout their native range, throughout shad native range. 7 of those unique genetic regions were up in the Canadian waters, and they generally associated with individual rivers. As we move further south into the US waters, we see that basically the New England and Mid-Atlantic regions cluster into a single genetic unit, and then the southern region is also considered a single genetic unit. And it's these latter 2 units that make it very difficult to perform population assignment because there's not a lot of ability to differentiate between rivers within particularly US waters. This was shown very succinctly in a report by Meredith Barton and Lauren Prasco, where they looked at the stock contribution of American shad in the mixed stock fishery in the Delaware Bay. They sampled 14 populations and 16 microsatellite loci that were an overlapping panel of loci that were used in the Hasselman study. And what they found is when they did individual assignment at the level of individual rivers, they had an average assignment accuracy of around 30%, and it ranged widely from 4% up to 91%. And the highest assignment accuracy was at the most differentiated populations at the edges of the species range, but in the middle portion of the range, the assignment accuracy was very low. And so recent advancements in whole genome sequencing are providing an opportunity for us to overcome this limitation. Here is a comparison of a couple of common whole genome sequencing approaches. The top approach is the low coverage whole genome sequencing data that we'll be using in our analysis. It has some particular benefits, which is its breadth of coverage, where it surveys nearly the entire genome. It allows individual level data, large sample sizes, but one of the major limitations to this approach is that the low depth of coverage results in inaccurate genotyping. And I'll address how we overcame this issue in the next couple of slides. This is compared to another approach, which is probably the most common approach currently used in genomics, which is RADseq. This approach has the benefit of a high depth of coverage, which allows accurate genotyping. However, when this approach is used, it surveys around 1% of the genome, so there's about 90% of the genome that is not surveyed, and so informative polymorphic regions are often overlooked. This was succinctly shown in a recent study by Sarmak et al. In 2021, where they compared whole genome sequencing data and RADseq data for the same populations of warblers. Here we show Manhattan plots with chromosomes indicated on the x-axis and FST or genetic differentiation values on the y-axis. And these are values for the individual SNPs that are shown on the screen. And when you look at the WGS or the whole genome sequencing data on the top, you can see these peaks of high differentiation that are identified with the red arrows. But when you compare that to the ddRAD data, there are highly divergent SNPs, but there is limited ability to identify these peak regions of high information content. And so the limitation to this approach, again, as I mentioned, was that we cannot genotype these accurately with this data, and so we had to use a different approach to address that, which is a targeted sequencing approach known as genotype in thousands by sequencing, or GTseq. This approach can accommodate thousands of individuals into a single library. It allows us to simultaneously genotype hundreds of SNPs, and it amplifies consistently, so there's very little genotyping error. And so the purpose of this study was to develop the tools necessary to accurately quantify the incidental bycatch of American shad at the level of individual component stocks. To do this, we generated a panel of highly informative SNPs for the American shad using the low coverage whole genome sequencing. We then converted this panel into a cost-effective high throughput genotyping assay. And then we used simulated empirical data to test the ability of the newly developed panel to assign individuals to their correct source population. And then lastly, we estimated individual stock contributions to the Delaware Bay and the Bay of Fundy mixed stock fisheries. The study design for this project included 12 reference populations. It spanned the range of shad from Canadian waters down to St. John's in Florida. For the low coverage whole genome sequencing data, we sampled 31 individuals from each population in 2019, with the exception of the Chowan and Roanoke, which were samples that were collected in 2018. For the GTC data, we used the exact same samples plus additional samples that we had. So we had between 48 and 82 samples for our reference populations. And for the mixed stock samples, we had 86 for the Delaware Bay and the 64 for the Bay of Fundy. And it's important to note that the Delaware Bay samples are the same samples that were used in the Bartran-Prasco analysis. So for the reference populations of the low coverage whole genome sequencing, we had 371 individuals. We generated 3.3 GB of data. We had a mean depth of coverage around 0.85x, a breadth of coverage, so we covered about 73% of the genome, and as a result, we identified 12 million biallelic SNPs. When we conducted principal component analysis to identify population genetic structure, we see that we were able to resolve genetic structure to a higher level than it has been previously possible. This PCA plot is orientated in a north-south axis with the Canadian populations at the top of the figure. We see that they're the most differentiated, and that corresponds with the Hasselman results. As we move further south into the Mid-Atlantic region, we see there's 4 or 5 individual clusters that form in that region, showing that we are able to differentiate those populations. And we see another 3 or 4 clusters in the southern region. So again, for the most part, we are able to distinguish the vast majority of these populations. So for developing the panel, we used a FST ranking approach. We focused on populations from the Mid-Atlantic region. We did this for a couple of reasons. The first was this is the region that has showed the lowest differentiation, and we really wanted to resolve that. And then secondly, we're particularly interested in the Hudson River, so we wanted to capture the diversity around that region. We then selected the top 250 SNPs from these comparisons, which resulted in about 1,800 loci. We LD pruned them down to about 640 to give us independent data. And then when we looked at this, and the 644 SNPs are the pink SNPs or the pink triangles that are indicated here in the figure. And then we added another 9 SNPs from the chromosomal inversion on chromosome 6, and the manually selected 63 additional samples from regions of the genome that were of particular interest that hadn't been captured in the FST ranking, and those are the red boxes shown in this figure. So from these SNPs, we were able to design 400 primers for 405 loci. We did an optimization run where we used a subsample of 96 individuals, and through this optimization procedure, we were able to retain 300 SNPs. For the data generation analysis, we had 852 individuals. From that, we were able to generate genotypes for 254 microhaplotypes. These microhaplotypes had a mean number of SNPs per locus of around 9.2, and the number of haplotypes per locus ranged between 2 and 33. So when we applied this to a situation where we could analyze the accuracy of population assignment, we first did it at the level of the individual rivers shown here in the top figure. The individual rivers are located on the x-axis, and the proportion of correct assignment is on the y-axis. And the dashed line that goes across the figure is that benchmark value of 30% that was established in the Bartran-Prasco analysis. And what you can see here is in all cases, we significantly increased our assignment accuracy. However, the Kennebec, Merrimack, and Connecticut, we were not overly satisfied with the assignment accuracy for those populations, and also the Chowan and Roanoke. And so we ended up collapsing those into reporting groups. And when we did that, we've had an average assignment accuracy of over 80%. And I think it was around 86%. And the lowest value was 80, and the highest value was 97%. And so when we then took this panel and we used it to assess the stock contribution in the Delaware Bay mixed stock fishery, we see the proportional stock contribution shown here on the x-axis and the individual reporting groups on the y-axis. And this is orientated in a north to south direction. And what we can see here is that the vast majority of fish that are captured in Delaware Bay come from the Delaware River, around 48%. And then there's 16 and 18% that come from the Hudson and Potomac, respectively. And then there's a few other fish that are found from some of the other stocks, but those are the major contributors. We see a slightly different story when we look at the Bay of Fundy analysis. There's a number of stocks that contribute to this fishery. However, the vast majority of these fish come from the Miramichi of Canada. So our results show us that using SNPs allowed us to further resolve the population genetic structure of American shad along the Atlantic coast of North America. The improved assignment accuracy allowed us to better estimate individual American shad stock contributions in the mixed stock and bycatch fisheries. And with this information, we were able to identify component stocks that are likely to be disproportionately impacted by the incidental bycatch. And this will allow us to better assess the potential effects of these efforts on restoring depleted stocks. And in this case, we're really focusing on the Hudson River. Some of the future work that we've got going on right now is we are working to quantify American shad stock composition for additional bycatch and mixed stock fisheries operate along the east coast of North America. We are also assessing the spatial and temporal variability of proportional stock contribution of mixed stock assemblages along the east coast using the NEMAP and other nearshore trawl survey data. And lastly, we are comparing our current genotype-based target sequencing approach with a recently developed genotype likelihood-based approach that was developed specifically for low-coverage whole genome sequencing data that is implemented in the software package WGS Assign. And with that, we'd hope to further improve upon our ability to accurately assign individuals at the level of the individual river or estuary. And with that, I will like to thank our funding sources, which is the New York State Department of Environmental Conservation, the Hudson River Foundation, and the U.S. Geological Survey, and also for all the technical support and samples that were provided by individuals over the years. And with that, I will pass this over to Maluska for her to talk about the Alcine Tissue Repository. Thank you.
Hello, everybody. Can you hear me?
Yes.
Yep, sounds
Okay. Good afternoon. Today I'm going to give a quick update on the Alcine Tissue Repository. I am with the USGS Eastern Ecological Science Center. Can you go to the next slide? We have received a total of 991 samples for ALEWI for about 24 locations, 3,486 samples for American shad for 44 locations, 1,240 samples for blueback herring for 19 locations, and these samples come from 2008 to 2024. Most of the samples are for the last years. We are going to be soon receiving some samples, some mixed stock samples from NIFOP and from the Bottom Trawl Survey. Can you go to the next slide? We want to thank to the many individuals who had already contributed to our tissue repository. I tried to list most of them, if not all of them here. And we continue to welcome additional samples and can provide sampling kits. That's basically it. Thank you.
Let's see, Ryan, for you, Sheila Eiler asked if the genetics research was published, the shad genetics research, or where we might find your findings.
It's in progress right now. We just got that data 2.5 weeks ago. And so I finished it earlier this week. So we've got a draft of the document already written, and now we're just kind of going through that process. So it should be out, at least in review, I think, by Christmas time.
Okay, great. As we're waiting for more, oh wait, we got a question in the chat from Ted Castro Santos. Can you clarify whether and to what extent your analysis assumed low gene flow from the quote unquote non-mixed stock rivers? Can
you state that question again?
Yeah, so Ted says, can Ryan clarify whether and to what extent his analysis assumed low gene flow from the non-mixed stock rivers, I guess as you term them? Or,
Yeah,
or better, in those rivers. Ted, if you want to raise your hand and ask your question, certainly I can do that.
Yeah, unmuted. Maybe now. Thanks. Yeah. I guess I was trying to. It seemed the way you presented it as though you were assuming that you had the mixed stock rivers and non-mixed stock rivers, and it seemed like you were assuming, that there was some genetic purity in those non-mixed stock rivers as you were doing that. I was just curious as to whether that was a prior that you're putting into your analysis, or if you were able to establish that within those rivers as well. It wasn't really clear to me how you were doing that.
Yeah, I'm still a little bit unclear on what you mean by mixed stock river. Are you talking about our reference?
It was in your slide. You called the Delaware and one other, I forget which it was. You had two rivers that you identified as mixed stock, and the others, it seemed like you were assuming were not.
So maybe I wasn't clear there. Sorry, I was trying to fit that all in a very short time. So we had the 12 reference populations, which were breeding populations, which, though there may be strays and some other things in there that we've more or less tried to weed out, those are considered to be largely pure stocks, at least for their various rivers. For the Delaware Bay samples, those were fish that were caught in the fishery and then were assigned back to those rivers, which were in that case, the Delaware was the predominant supplier of those fish. And then for the Bay of Fundy analysis, again, that was the same thing where the predominant contributor to that was from the Miramichi. We do have some analysis that we were working on to look at if any of these fish are assigning to the wrong population because we don't have their reference population sampled. That's one of the problems with some of this genetic analysis is if you don't sample the reference population, the analysis wants to stick the fish somewhere, but there are a bunch of methods that can kind of parse that out. We've done an initial round of that for this to just make sure there's no obvious individuals that are being misclassified, but we're still kind of working through to clean up some of the last bit of that.
That helps. That helps answer my question. And I guess, again, that notion of, because there's a growing body of evidence, slowly growing, that there may be a fair amount of straying, in particular in the virgin year of spawning among rivers. And I just wondered about how sensitive your analysis would be to that assumption of purity within the rivers being, not being substantiated. So Bay of Fundy, that makes sense. We expect that to be mixed stock. And then you went ahead and put the Delaware in, which surprised me a little bit. Unless you think there's a good reason, we have a sense of how the Bay of Fundy is being used by the species. And I'm talking to fishermen in the Delaware, they seem to think that Delaware Bay is being used rather similarly. And I wasn't sure if that was what you were starting from, that assumption, or is your analysis actually robust against the assumptions that you're making about those other rivers being pure stocks?
So, so two things that would come in here is the first one is if it's a recent migrant and it's not like spawned and reproduced and mixed back into the fishery. So if it's a first generation migrant, we can detect those. And when we do the actual self-assignment where we take them and assign them, those would be the individual that are then misclassified and assigned to another river. We then are exploring why those fish are being misclassified to see if they would be considered like a pure stock of a different river and there's just a first generation stray. And then we're also trying to look at if some of these individuals are actually hybrids between multiple stocks that is a result of straying, and we're trying to also parse out how much influence that has on our assignment accuracy. We haven't got to that in a great extent, but I was actually just talking to one of my collaborators today about some tricks we're going to use to try to get at that question more. So that is something that we are looking into. I mean, there's no way to probably completely 100% rule out the inclusion of some strays into our data set. But I think with the power of our markers, we are able to discriminate individuals. And if they misassign to the river in which they were sampled from, we are making our best effort to try to figure out where those fish come from, and if they are coming from a neighboring river or from a different stock.
Great, thanks for answering Ted's question. I think he touched on that well, and just wanted to note that Sheila Eiler further noted that once this is published, it'll be an important source of information for the Delaware Fish and Wildlife Management Co-op, because there's some discussion around when those chatterbait caught in the Delaware Bay, whose fish are those, right? So this is a great this will be a great way to start to look at that question. We have a hand from Jason Didden, and then one more in the questions box. Jason, do you want to go ahead?
Thanks. 2 questions. One, so like I had always imagined that Delaware fishery was like a spring fishery where fish are, running up the bay. But is that like a year round? I mean, are they getting those shad year round? I was just curious, like when those samples are obtained.
Yeah, I'd have to go back. I don't have that off the top of my head, but I think they are spring caught where they were assumed to be fish running in, but I don't know off the top of my head where in the bay they are actually collected. I think if you are further up in the bay, you have a higher probability that they're going to be Delaware fish. But I think some of these fish from 2018 and 2019 might have been sampled kind of throughout the bay, and that's where fish that are moving up and down the coast may have been sampled in the outer regions of the estuary, which then captures a lot more of those fish from the Potomac, from the Hudson that are moving up and down the coast. So I believe they are spring, and I believe they basically were sampled from the entire extent of the bay, but I'd have to go back through the actual samples there to confirm that.
Sheila Eiler raised her hand. I'm sure she could speak to that as well.
Yeah.
Sheila, do you want to chime in there? And can we unmute her?
Sorry about that. Sheila, your mic is live now.
Sorry. I was waiting to be unmuted. Thank you. Sheila Eiler with Fish and Wildlife Service, work with the Delaware River Fish and Wildlife Co-op. Important information that you've presented, so thanks for that. We'll be looking forward to using that for management. As far as the fishery that occurs in the Delaware Bay, recent years, the fishery has really not taken very many shad, but it is a spring fishery. So it's during the run when the fish are coming in the river. I think the way we understand it is there's a lot of fish in the bay in the late winter and early spring. Some of those do go up the Delaware, especially as you go further up into the bay. But some that are closer to the mouth might actually leave the bay and go to different rivers. So, but it is a spring executed fishery. It's not year round.
And Sheila, that fishery is primarily targeting striped bass. Is that correct? Or is it a mix of other fisheries as well?
At this time, yeah, it's striped bass now, and some of the regulations have changed again. So the encounter rate is much lower, I think, than historically. So the landings are much, much lower. We're in the hundreds of pounds instead of tens of thousands anymore.
So I don't know
Thanks.
if you have the number of samples to do it, but it could be interesting to see, like, does that proportion change at all if it's, earlier or later or near the mouth of the bay or further up. But again, I don't know that you have the samples to do that. So my second question was, so now that you have this kind of set up, can you pretty much, take samples from, say, the squid fishery in the summer and essentially fairly easily subject that to a similar analysis to see like where those shad are coming from?
Yeah, so I'm trying to remember what your first question was. So we have 2 Delaware Bay sampling years. The one that I presented here is 2019 because it was just matching up with all of our other samples when we had initiated the study. We only had less than 100 fish there. But for 2018, we received 256 fish. And at that case, we actually have probably enough fish to start doing location and temporal variability in the proportional stock contribution. So I have that data, we have it sequenced. I am just working through that as well. So we do have, again, the multiple years for that fishery. So that will be included in the manuscript when the time comes. And then your second question is about how easily we can basically implement this approach. So what we were trying to do here is the low coverage whole genome sequencing is kind of a beast, and processing that is quite hard. But the genotyping assay that we went after is very quick, very easy. It's get some samples, make a library, sequence, and add them to the collection. So this really is a, yeah, if we have samples, we can start doing mixed stock analysis quite rapidly with this. The only thing that I would probably suggest as we move forward is to start expanding the number of reference populations. We have a total of 44 rivers surveyed that we have data from, but for the funding, my time and everything that I had, I was only able to do the initial 12 that we were sent in the first year of the analysis. So yes, we can expand the spatial coverage of our reference populations, and we can pretty easily incorporate any additional samples into this panel and assess their river of origin with a relatively high accuracy.
I think you answered Jason's question sufficiently. I see Sheila's hand is up. Is that left over, or do you have a question?
Nope, I'm good, sorry.
Ryan, there is one question in the questions box from Heather Evans, who asked if you move to the ICWGS, the whole genome sequencing, instead of the GT-seq, I think is how you termed it. What will the cost difference per sample be?
Yeah, unfortunately, I'm not probably the person that controls the purse strings. So I'd have to send that to Nina. Unfortunately, she was unable to be here. She's flying back from a conference in Colorado. So I can get that information. But I think, at least in terms of the library prep for the GT-seq, the cost is a few dollars per sample. For the whole coverage or the low coverage whole genome sequencing data, it's significantly higher, but the costs are rapidly coming down. So it's becoming more feasible to do population level analysis on that. But I don't know the exact numbers off the top of my head without some input from Nina.
Okay, I guess, Heather, if you want to indicate in the questions whether you'd like us to follow up with Nina and Ryan via email, include you, we can do that. Just let us know. I had a question for you, Ryan, about is there any chance that this this work would be further extended to river herring? Yeah, I know American Chat has been a long-running focus, but didn't know if you had talked about other thylacines in your research.
Yeah, so there's been a lot of great work done in river herring. They've kind of pushed the next generation sequencing faster than Shad had moved. But as I kind of showed in my talk, they had used the RAD-seq approach, which was very powerful and very useful at the time. But as I mentioned, that approach misses some of these polymorphic regions that don't allow you to get such a fine level of resolution. And so based on their work, which is why we kind of took the approach that we did to see if we could improve on it. And so we are very interested in expanding this approach to river herring and see if we can improve upon the stock assessment for that group of fish as well. But as of right now, I don't think there's anything in the pipes to initiate any of that work without further discussion.
Got you, thanks. And then for Melissa, I was wondering, you noted that you were open to receive samples, tissue samples, and you said you could send kits. How do should folks reach out to you directly via email or others in your lab just want to make sure that, you know, those that are interested in providing samples know how to get that process started if they're not involved already.
Hello, yes, I can provide my email on the chat. Yes, you just have to contact me and we can talk about, and if we can use the samples, we can send you sampling kits.
Great.
So
Go ahead.
So if I can chime in on that, one of the things we ran into with our recent analysis is we actually had samples from a number of fisheries sent. And the unfortunate part is the NEFOP samples that were sent to us, they came in such a state that recovering DNA from them was virtually impossible. So we may want to consider having a discussion about how those samples are being handled, how they are being processed, because I don't know the chain of custody, but somewhere in that chain of custody, these samples are being exposed to conditions that are leading to DNA degradation. And we had a few hundred samples sent to us, and we were only able to recover a few dozen. And so they were in real poor shape. So that might be a discussion for the future, is how to get these samples in a quicker to the repository so that they're in better condition for this type of analysis.
Yeah, no, that's a great point. Are there any like standard operating procedure documents or guidance documents out there that folks that are interested in sending samples could refer to, like, you know, keep an eye out for temperatures, or you think, you know, just things that folks need to be aware of, that something that we could easily point folks to?
So Maluska might have the answer for that for the repository. I know we've sent around a list for collecting reference samples. It's a little bit different for them because we have people in the field that are collecting the fish. They take a fin clip or a mussel plug and they send it to us, and it's handled really quick and it gets to us quick. Again, because of the chain of custody and how these fish are being caught in the fishery, how long they're on the boat, how long they're being handled, when they get frozen, how many times they're thawed. Like, I just don't know what happens there, but the quicker we can get the tissue in a tube preserved and sent to the lab, the better.
Okay.
And we can get you those if people are interested. And like I said, maybe Maluska could chime in and they might have something that they can send out immediately. I don't know.
Yeah,
The NEFOP. Oh, sorry. Go ahead, Melissa.
Yeah, we send sampling kits with RNA later. We have gotten better results with those sampling kits. Ethanol has not worked that well, but we are not getting many samples with ethanol anyway. But the worst are the mixed stock samples that are like frozen, and when they arrive to the lab, they are already decomposed, and we have not got good results with those. But yeah, we send a sampling protocol for all the kits that we send.
Okay. Jason, I see you have your hand up. I assume it's related to this question.
Did you also say you're starting to get samples from the NEMAP survey?
Yes, we've sequenced a large number of fish from that survey, and they will be incorporated into the next piece of analysis that we're going to be doing. So we'll have some information on the proportional stock contribution seasonally and by management grid up and down the coast based on those, and that will be a piece of analysis that will be coming out in the future.
Cool, thanks.
Yep.
And Ryan, on the NEFOP comment, are you guys still working with that program to collect samples? And if so, you know, is there someone that we can help reach out to kind of help, you know, convey your concerns around the sample quality there?
So my time is coming to an end, so we've really pushed that to Dave and Maluska to continue with those requests. I know we have basically an ongoing request that's been put out each year for additional samples. I know just because of effort and number of observers, the number of samples has declined over the last few years, but I know there's a request being put out each year by the repository and we'd put out for the last couple of years. But our lab specifically isn't putting out any more requests, but they are being requested for the repository, so the work could be done in the future.
Gotcha. Thanks. Just want to make sure we're closing the loop on any issues there. Okay. Well, great. Thank you for offering to come and present an update. And yeah, we'll look forward to seeing the publication. Good luck getting it out the door.
Awesome. Well, thank you so much for your time.
Yeah, and Melissa, thanks as well. And you know, happy to take updates on the tissue repository whenever there are some to share with the forum. Thank you.
Okay. Thank you.
Thank you.
All right. Well, thanks for having me here. I haven't been part of this group previously, but I'm excited to talk with you all. I'm at the Center for Limnology at University of Wisconsin now, but this is work that I did while I was at Rutgers University with a bunch of collaborators there. And I wanted to call out in particular Anthony Vistano, who was my lab manager at Rutgers and was really responsible for implementing a lot of the study that I'm going to talk about here. I wanted to point out at the beginning here that the study is published and it's available online, open access, and that's the link there. I can send it to you guys or put it in the chat later on here, just so everyone has access to it and can go back to the document. So I've got some background here from a previous presentation. I hope you'll bear with me. I know for most of the folks in this call, you're pretty familiar with Allocenes, American shad. So American shad, obviously quite an important species in the Raritan River. They were historically extirpated, but there was stocking and some fairly restrictive fishing regulations after the stocking that managed to bring back a small restored population of the Raritan. River herring, also important. I'm not going to distinguish here in my presentation between blueback and alewife, largely because one of the data sets is a video data set, so we have limited ability to distinguish them. Both are present to some extent in the Raritan. So we know they're facing population declines. Margaret's presentation really laid out the different reasons for that. There was never significant commercial fishing in the Raritan River, but certainly recreational fishing, and much more importantly, the habitat loss, including several dams, as well as pollution. One of the dams on the Raritan was actually built to hold back the pollution from a paint factory. Largely to keep local residents from getting freaked out when the color of the river changed when they were making different kinds of paint. So just a bit of an idea of the kind of pollution we're dealing with. This is a heavily industrialized river in the past. And fish ladders can, of course, potentially improve access to upper reaches of the rivers. There is a fish ladder in the Raritan River that is the focus of this study, called the Island Farm Ware, and that is currently the first hurdle for Allocenes, shad, and river herring that are making their way up the Raritan. There was previously a downstream dam that was notched a couple decades ago. So at the point we started this study, the Island Farm Ware was the most downstream obstacle. While the study was going on, a few dams were removed upstream of the Island Farm Ware on the main stem Raritan and also on a tributary, the Millstone River. So we have covered a period here during the study where dam removal took place. The Island Farm Ware is used to maintain the water level behind the dam such that the water supply is assured for a lot of northern New Jersey. So this is not a dam that's coming out anytime soon. It still performs a critical function. The Island Farm Ware fish ladder is a vertical slot fish ladder. The entrance is right over there. That graded area just upstream from there is the fish ladder. The device to the right over there next to the fish ladder is attraction water. So there's some ability there to adjust the attraction water flow through the Island Farm Ware. So our questions here: how efficiently can allicines pass through the fish ladder? We studied that using pit tags and a receiver array at the fish ladder. And then we also using video from a viewing room at the upstream exit of the fish ladder. I want to present some information about which species have used it, and also do run size reconstructions for the shad and river herring passing through here. As somebody alluded to before, a lot of our data comes from on run sizes comes from passage. Monitoring them at the upstream end. That, if you want to estimate a total run size, we also need to correct for the inability of a potentially large fraction of individuals to make it that far. So that's what we're trying to do here. So starting with that first question. We used pit tags, passive integrated transponder tags. I think probably most people are familiar with that here, but it's essentially easy pass for fish. It's the same technology, tiny little tags. For river herring, they're about the size of a long grain of rice, and they were injected with a large gauge needle there. For the shad, we were able to use a slightly larger tag with a better detection range. That one is about the size of a Tylenol cap. And this is what the island farm ware here looks like on the inside there at the bottom. You can see that on the right side, there's the ladder entrance. So the fish have to find that entrance, and then they make their way through a series of rooms connected by vertical slots. And the idea here is that the vertical slots are offset, and that baffling essentially controls the current, reduces the current so that they can make their way through. That's the theory in any case. We'll see about the practice in a second here. In that photo in the upper right, you can see that slot. That is the entrance, and within the slot, you can see, I hope you can see, there's a piece of PVC there. Essentially, our antennas, our pit tag antennas, are wire inside a PVC pipe that slots into these different parts of the fish ladder that you can see here. We started with a receiver at the ladder entrance and the ladder exit. And then later on, we got more ambitious and more curious about where exactly within the fish ladder fish might be having trouble. So we installed a couple internal antennas as well. So these antennas then record when an individual tagged fish passes that location. Okay, so we captured fish using a combination of seining and angling. Earlier on, we also tried fyke nets as well. These are relatively small populations that we're talking about, and of course their runs are really boom and bust. Often there'll be nothing there, and then if you hit the right day, you'll catch a dozen or so. And so we mostly for the river herring did seining, spot a few kilometers downstream from the fish ladder. It's a great way to involve a lot of undergraduate students. I was at Rutgers University at the time, so we had large crews out there doing the seining. And then for shad, angling proved generally more effective, particularly in the pool right downstream from the fish ladder, as you can see on the right-hand side here. Just to make sure we're on the same page with respect to the different fish passage terms, we refer to attraction time here as the time from tagging to its fish's first appearance at the fish ladder. So you tag it, and then eventually, some hours or days later, it's detected for the first time at the entrance. That's attraction time. Staging time is how long until it's last detected at the fish ladder entrance. So, fish don't always just find the entrance, head right through, get it all done in one shot. Often they find the entrance and then they mill about at the entrance for some time before they're finally detected for a last time as they make their way through. And then transit time is the time from when they were last detected at the entrance to when they were detected at the exit. At the exit, we generally just detect them once. By the time they make it all the way there, they're heading upstream and they leave. So that's transit time. And then passage time is that total from the time we detect we tag the fish to the time it makes it out the exit at the upstream end. Okay, so let's look at the results here. Overall, American shad had shorter times for almost all of these metrics, but again, they were generally caught closer to the latter. So attraction times averaged 5 days there, staging time about 2 days, transit time a little over 2 hours on average for shad. So they're making it through, but it's taking them a while once they get in there. And the whole passage time, a little over a week, 8 days or so. In contrast, the river herring are taking longer. So attraction time about 12 days before they're first seen there at the fish ladder entrance. And then on average, they spend another 5 days milling about before they make a go for it. Transit time, relatively quick. I should point out here that these river herring numbers, I don't want to give away the punchline, but the river herring numbers are based on a very small number of individuals that actually made it through. Passage time, 15 days. That 15 days has no error bars associated with it because out of all the river herring we tagged, only one made it through in the same year that we tagged it. So yeah, the passage rates here. So these are the number of individuals tagged in the left-hand bar, the number of those individuals that reached the ladder and passed the ladder here. For river herring, we were able to attempt to correct for fallback. So fallback is the behavioral response that's sometimes observed of anadromous fish that essentially go downstream rather than going upstream after they're tagged. Seemingly a behavioral response to the trauma of being tagged. Now, detecting this and estimating it is important, but it's also really difficult. You essentially have to have an additional receiver either downstream of where you tag or upstream across the river that allows you to estimate how many gave up essentially versus how many continued on in their migration. We couldn't do this on the Raritan. It's simply too big a river to be able to do this feasibly, and water level fluctuations are pretty extreme there. But we were able to use the same exact methods and use an additional receiver, a cross river receiver at a smaller stream in southern New Jersey. So that's where we estimated the fallback. And from that study, the river herring fallback using these same tags, same handling methods, was estimated to be 52%. So about half of the tagged fish might have fallen back. So we can present numbers then for river herring with and without that fallback correction. Either way, passage for river herring is poor. When we look at the total passage rate here, what we did was a hierarchical Bayesian approach here, where each year passage for each year is nested within an overall passage rate. And that's because within each year of the study, the numbers were small enough that there's a lot of uncertainty, and mostly zeros for river herring passage as well. So we wanted to be able to efficiently keep track of uncertainty in those numbers. What we see is that for American shad, we've got a 41% passage rate, some variation from year to year. The red X's here are the passage rates in any particular year, and then the estimates from those years, because again, they're brought back toward the global mean by that hierarchical Bayesian model. They're brought back to that black circle there in the center. So fair amount of variability from year to year in the raw numbers, much less variability in the estimates within the hierarchical model. So 41%, maybe not great, but certainly a heck of a lot better than for river herring, where the average was 0.5% passage rate for the unadjusted. And if we double that essentially after correcting for fallback, we end up with 1.1%. Either way, river herring are having a really tough time making it through this fish ladder. Okay, we can now combine those passage rate estimates with information from continuous video monitoring during the fish migration period to estimate total run sizes. And that's what we've done here for the Alicines. We also just have all of the species identified, and I'll just pass through those kind of quickly because I think they're interesting in some ways. But this is what our setup looked like at the upstream end of the fish ladder right before the exit. There is a plexiglass window and a white backdrop on the other side there. That makes for relatively good video quality. Relatively good. This is not a glass bottom boat in the Caribbean or something like that. Still dealing with a muddy river, but generally conditions good enough for us to identify the fish. I say us. There was an army of undergrads that viewed this video. I hesitate to take a guess at how many budding young ecologists I turned into dentists or accountants or something else, because I assigned them watching fish video as their first ecological field research experience. I feel bad about that. Hopefully pretty soon there'll be an AI approach to this that will require no human being to sit in front of all this video. But that is what we did here. Passage for American shad, you can see only available when this analysis was done for these 4 years of data where the video monitoring methods were very consistent. But you can see, generally spread out over several weeks, but the real peak about mid-April to early May. The students would talk about sucker week, in part because sucker would pass during a very specific time, and very few of them seen outside of that window. Not as popular as Shark Week, but we're going to talk to the Discovery Channel and see what we can do. Other species here, quite a few different species seen, carp and catfish in particular, abundant there. Quillback, gizzard shad, bass, also very abundant. I should also point out that upper left corner there, unidentified. So unidentified fish made up 21% of the individual fish seen in the video. So that number we did not try to attribute or sort of assign proportionally or anything like that. We just left them as unidentified. So up to 21% higher numbers for any of these species potentially. Okay, keep moving through these. We can come back if anyone's interested in any particular species here. We used these counts from the fish ladder and then bumped them up by the passage rate estimates to come up with a run size estimate for American shad and river herring here. This is from the paper. The first thing to point out is that this is a log scale on the y-axis, so a lot of variation, but also just a lot of uncertainty here. That uncertainty is essentially the uncertainty in the passage rates translated over into the run size estimates. The dashed line on the bottom is the video counts. For river herring also, I'll point out here that we don't estimate an upper bound because the tails of the distribution for passage rate for river herring came very close to zero. That upper bound on the run size got ridiculously large. So we're only showing it here with the lower bound estimated. Essentially, they're somewhere between 1,000 and an infinite number of river herring in the Raritan River. When we look at the actual numbers here, the mean estimates, we're talking about 103 to 2,600 shad in an annual run, and river herring runs of about 1,500 to 50,000 fish. So just to sum it up here, shad have some modest difficulty with the island farmware fish ladder, but for river herring, it's really bad. It's essentially not working for river herring. And so New Jersey DEP, who funded this study, has plans underway to produce a nature-like fishway as an alternative to that ladder. I'll stop there and just say thanks to all of the people who've been involved with this. I'm not mentioning all the undergrads, but there have been a lot of them who came back for multiple years, and I put them up here. Also, Warren Leach from Oregon RFID, we had him on speed dial during the early years of the study while we were getting all of the pit tag gear to work. And Alex Harrow from USGS, who was really helpful in getting our receivers dialed in. Thanks, I'm happy to take questions. I'm happy to take questions, but I can't see them, so maybe somebody else could.
Yeah, we'll help field questions.
Thank you.
And thank you so much for coming to present the work. Yeah, I know I reached out because I saw the paper published and figured it'd be great for those who weren't aware to get a little update from you. If folks have questions, feel free to answer them or to raise your hand or ask them in the questions box. I see one from Ted Castro-Santos, actually from Aaron Heisey at USGS. Did you see differences in the time to approach between the seining and angler captured fish? Also, how did you account for the effects of time varying covariates like temperature and discharge on passage rates? So 2 questions there. First being difference between the different capture methods.
Yep, we had so few shad captured in the seine that we didn't attempt to do that. We had a couple though, so I could go back and look at that. As I said, I think that probably does account for some of the difference in the time to first detection at the downstream entrance. Other covariates, we didn't attempt to relate in this paper the environmental covariates to passage rates, but we have them all, and that's certainly something that could be done in another analysis. Also, that phenology information about all the other species involved here and their timing of passage, I think that could be interesting to look at some point as well. And if anyone was doing a broader study on that, we'd be happy to contribute that data.
Great, thanks. And I'm not sure if you might know the answer to this question, but Alan Weaver asked, let's see, what's the elevation difference from pool to pool, and what's the V through the slots is how he put it.
Gosh, the elevation difference, I don't know. I think we're talking about something like 8 to 10 feet total elevation difference, but I don't know within each chamber of the fish ladder. The slot width within the ladder, I would say probably about 10 or 12 inches. I'm going by memory there. I might be wrong.
Right.
It's been a while since I was down there in the fish ladder.
Okay, I assume maybe you think that information is presented in the publication.
It's not in the publication, no.
Okay.
No, if you want to follow up with me, I can try to track down that information though.
Yeah, sure, Alan. Yeah, just I guess feel free to put something in the questions and we can follow up if you'd like that information, or if there are others, feel free to enter it in the message board. Not seeing any hands, so I have a question, or really a comment, and you brought this up about the Army of Undergraduates having to watch the video, which is funny. I wanted to note that Rob Vincent from MIT Sea Grant has been working on developing an automated video river herring monitoring system, I think using AI, if I'm correct. I'm not sure if you've had contact with Rob Vincent, but just thinking if you've got a validated data set with human eyes, I'm wondering if that would be a tremendously valuable data set to then help train that AI model and maybe spare some future students the sitting and watching video.
That sounds lovely. I would definitely be up for that, and I'll follow up with you to get his email. I had at one point a non-thesis master's student working on this, developed an algorithm using YOLO, which is one of the machine learning algorithms for computer vision. And it looked promising, but then of course she developed really marketable skills and got a job and never looked back. So I think there is some promise there. The thing we could never really get the AI to do, and this is frustrating, is to recognize that all the fish move from right to left in the frame, they move upstream, and all the non-fish objects move from left to right. Somehow that's something that's so obvious to the human eye, but the AI didn't seem to be able to pick up on.
Well, I will. I'll put you in, or I'll reach back out to Rob Vincent because I'm looking back. The last time he reached out to me about this project was about a year ago, and I'm not sure what the status is of that effort, but I'll reach out to him and see if should he follow up with you, I guess, if he's interested in.
That would be great. Yeah, I mean, we have the annotated video, which I think is a pretty good resource for training the AI.
Yeah, great. All right. Any last minute questions for Dr. Jensen here? Raise your hand or enter them in the chat. I'll give it a minute.
I'm excited to put a New Jersey time series on the map there for the next stock assessment. I think we just barely fit your criteria of 10 years. So hopefully I can do that next time. Yeah.
Great. Well, thanks so much for joining this group. Feel free to don't be a stranger. Join in future meetings. And
fantastic. Thank you, Jonathan. We
appreciate it. And that concludes the technical presentations for this river herring meeting, and we'll move into the update section. Our first update is from Henry Leggett at Smithsonian Environmental Research Center.
All right, excellent. Yeah, so my name is Henry Leggett. I'm an ecologist at or a postdoc at the Smithsonian Environmental Research Center, working with Matt Ogburn. We gave a longer presentation about all our lab's activities, at the last meeting, but I just want to give a short update on our projects with the Rappahannock Tribe of Virginia and George Mason University. If I can advance, yeah. So the biggest part of the studies I want to focus on today are our telemetry work. So we've been putting V7 ANOVA-C tags in river herring every season since 2022. The first paper from our tagging efforts was just published this year in MEPS. For this first project, we tagged 50 alewife in the Choptank River in the Chesapeake Bay in the spring of 2022. The main highlight is that 14 of these fish were tracked migrating to the Gulf of Maine and Bay of Fundy, where they were there for the summer and fall. And then we were able to track their migrations back south along the coast to the Chesapeake Bay. We followed up this study by collaborating with the Rappahannock tribe to tag 100 alewife in the Rappahannock River in spring of 2023. Because we tagged more fish, we were able to get kind of a clearer picture of the timing of the habitat use along the coast. So fish spend to late spring on Georges Bank, and then the summer and fall pretty close to the coast of Maine and Canada. And then that migration back south from those fish started in December, and again, they were using habitats that were very close to the coast during that return trip. Especially along Cape Cod and Long Island, and they re-entered the Chesapeake Bay in late January and February. Starting this year, so this spring in 2024, we got a grant from NOAA to expand the telemetry project across rivers in the Bay. So we tagged 50 blueback herring in the Patapsco, Potomac, and Rappahannock rivers. And then this next season, 2025, we'll tag 50 alewife in each of those rivers. Yeah, and we're also collecting samples for otolith chemistry and genetics. And we've got projects on deck working with the tribe to start some eDNA work and egg sampling to do some targeted restoration in the lower Rappahannock. Yeah.
Great, thanks for the update, Henry. Can you remind me, what is the life of those V7 tags?
Just over a year. So we're able to, in the Rappahannock this last season, we tracked the fish out, they came back, and then we were able to get one more out migration from the mouth of the bay before we lost the tags.
Great, yeah, so you can really close the loop there.
Yeah,
it's exciting, and glad to know you guys are doing some more work there to help paint the whole picture. Any questions? Raise your hand. Questions box. I didn't see anything come through in your presentation, though it was rather brief. And I appreciate you keeping us abreast of what you guys got going on. I'll give it a minute for any questions on this. We got one from Abigail Archer who asked if you installed receivers yourselves or used receivers that were already out there for other studies.
Yeah, so it's this is all through the ACT network and Matos, the collaborative network of receivers deployed throughout the bay and all along the coast. We have our own network of receivers in the rivers and some in the bay, but I mean, it all goes into a network. So the detections we have on the coast and up in the Gulf of Maine are with labs at the University of Maine or other state, federal organizations, anybody doing research. So it's yeah, bunch of different receiver arrays that went into this.
Right. Essentially, that's my understanding is like a data sharing arrangement, essentially, where there's a known set of tags out there, and when people get tags they don't know on their receivers, there's a way for them to cross-reference those other projects. So,
yep, it all goes into a single database. If you have tags, you'll get information from other people's receivers that have detected your tags.
Great. Yeah, the technological advancements there are really exciting. So thanks for keeping us up to date there. Yeah, with that we can move on to further down the Chesapeake, and we can go to Alan Weaver, who wanted to present on some of the dam removal progress in one of the systems down there. So with that, Ben, if you can make, or sorry, James, if you can make Alan a presenter. I think you had some slides you wanted to share with the group.
So yeah, so just wanted to take the opportunity to share this project that we are just completing. This is the Ashland Mill Dam removal on the South Anna River. This picture that you're looking right there was one of the last views of the dam with water flowing over it. The stop logs failed in May, coincidentally, and when they set up a webcam on Route 1 looking at this camera, we had a high flow event, and the water got high enough to overtop the dam for one last time before it was removed. And I believe that once this dam's gone, the fish will move from point A to point B, just as far as the title goes. So the South Anna River joins up with the North Anna to form the Pamunkey, which meets the Mattaponi, and that forms the York. So this is a Chesapeake Bay drainage impoundment. It sits right along the fall zone area near Route 1 and 95. The dam was 13 feet tall, a little over 200 feet wide, and it was built in 1916. There were several different dams that preceded this, dating back probably as early as the late 1700s. And it was used for hydromechanical to grind grain at Ashland Roller Mills for a long time, up until not too many years ago when they switched to only using electricity. And then after that, it was just sitting there defunct for the last couple years. And a fire at the building caused some loss to the overall historical context of this. So there weren't a lot of DHR requirements, but it is a lot of some unique things about this dam and some pretty interesting historical things. So the anticipated benefits were to reconnect over 200 miles upstream functional network miles. It was a very highly ranked in the prioritization tool for the Chesapeake Bay. It was in the top 1% of over 7,000 dams in the Chesapeake Bay watershed. And some of the dams that were ranked higher, just because they're still dams and they have fishways that aren't going anywhere, this dam was in the top 5. The hypothesis is simple: more habitat, more fish. We're targeting the Holocene species, striped bass, sea lamprey, and American eel. And there's also potential benefits for freshwater mussels, with the host fish being able to pass upstream into the previously blocked habitat. We've got some potential, for example, the federally endangered dwarf wedge mussel. The project converts over 2 miles from lentic to lotic. That's the functional impoundment, and that'll be used for the mitigation calculation for this particular project. And it restores the stream and removes a boating safety hazard. So the abbreviated history is that one of the first things I worked on in this position was trying to get a fishway built at this dam. That federal money ended up over at Bossier's Dam vertical slot fishway. We just heard about a vertical slot. That's why I was asking some questions. And so that money went to good use, and I'm glad that we didn't build the fishway at this dam, because now we had even more reason to try to get it removed. Then over a decade ago, it was almost going to come out as a permittee responsible mitigation project for King William Reservoir that Newport News ended up not being able to build. Their permit was yanked, and so no project, so no mitigation projects. About that time, I started working with Dr. Chaz Gowan at Randolph-Macon College on the monitoring plan for removal. And then we've been trying lots of different ways to try to get interest and traction, trying to find money to get the dam removed. Then back in 2020, Restoration Systems, which they changed their name, now they're actually part of Davie Mitigation and not really involved most recently, but they proposed a mitigation bank. And then Davie Mitigation, our department in Randolph-Macon, we started looking for money for that they could still do mitigation, but still have some federal money. The credits would have to be prorated, and that got too complicated. So we kind of dropped that idea of trying to commingle those two things. And then the last thoughts about getting a grant funding for this was Randolph-Macon was going to apply for grant funding to remove it. But then in 2023, Davie proposed a mitigation bank. So we decided we thought this was going to happen. So we reinitiated our pre-removal sampling below the dam, and Randolph-Macon College is joining in with us. They're also doing eDNA analysis. And I mentioned those stop logs failing, which was totally coincidental. So the people upstream thought that the plug got pulled early before it was even permitted, but that wasn't the case. Then in July, the Army Corps of Engineers and Department of Environmental Quality of Virginia, they approved their MBI, establishing their credits that they can pursue if the criteria are met. And then the demolition actually started back in September, and now the project is complete, and Backwater Environmental just is finishing. They just finished up their bank stabilization wall. So here's just a map showing it's about 10 miles from Route 54 down to Ashland Mill Dam. This is just into the Piedmont of Virginia, and we have a couple sample sites that will continue to sample below the dam and also sample above the dam. There's a little dam at Route 54 just upstream that when it's overtopped in the spring, I've studied that dam, and I believe it's passable by the target species and probably all species. And I'll just also mention that there's a VCU student used to work for us that is working on ichthyoplankton, Holocene ichthyoplankton as part of his master's project. And we're employing electrofishing, eDNA. There's going to possibly be some sturgeon monitoring. We don't know if they get this far up the system, but there's a possibility that they do. Maybe not in the spring, but maybe in the fall. So there we are in the spring. We found American shad, blueback. We did not find blueback herring this year, although we normally do. I think the timing when the river was too low or too high was right when we were hoping to find American shad in late April and May. But we did find 3 of the 4 Holocene species, striped bass, sea lamprey, and of course we're finding eels. And that's Chaz Gowan on the front of our boat helping me sample for the fish below the dam. Then for the mitigation credits, I won't go into a lot of detail here, just to introduce it. Everything's based on the linear feet that's restored. That's that 12,250 feet of the functional impoundment being restored. And so there's some direct credits that can be claimed for that. And the Army Corps of Engineers several years ago made a new policy that a dam removal itself could be mitigation as opposed to having to be mitigated for. And so that's where some of those credits come in. Our area of interest is the fish, of course, and so that's why we're involved with the monitoring. I was involved with the monitoring before and continue to be, regardless of how the project is funded. So all of our data that we collect is public information, and we have an interest in seeing how far up the fish go and if whether or not there's any population changes, hopefully increases. So the bottom line is, for the fish part of it, no fish, no credit. These fish have to be found at least in 2 years over the 10 years of monitoring in order for them to be able to get those credits released by the interagency review team in Virginia. So this is just an overview of the project players. We have the Davie Resource Group with Davie Mitigation, Wetland Studies and Solutions. They're all part of that same Davie umbrella. And it is Davie Tree, by the way, just a very large corporation with these subsidiary companies. And Backwater Environmental, they're out of North Carolina. They did the demolition. I mentioned that we've been involved with this project for many, many years trying to get fish passage. So again, having it be a dam removal is much better than building a fishway. And so we've provided technical assistance, and we're working on the fish monitoring, both pre and post. Randolph-Macon College is involved. Dr. Chaz Gowan has lots of students involved. He's got some colleagues there that are working on eDNA analysis. So it's a very good educational tool. Randolph-Macon College is right in Ashland. It's like 10 minutes from the site. So it works out great for student involvement. So this is some pictures of the project starting. The project began on September 24th of this year, and hopefully this will play. Hopefully that's playing. And this was kind of our money shot. This section of the dam where the stop logs used to be didn't have any rebar in it, and so this big piece of concrete fell over rather easily. But everything else was sort of slow going with all the rebar in the concrete. And there's just some of us celebrating. On the left there's our project manager from Davie and Dr. Gowan from Randolph-Macon. And then over on the right-hand side, my crew and our manager. That's Matthias, Alex, and Clint's our manager. So just lots of people were showing up that had been waiting for this project to happen for a long time. So it was a time to celebrate this dam coming out. There's a little bit of pictures on the process. They had, a backhoe, a ram hoe, a track truck. I think my favorite piece of equipment was the track truck for, basically getting all the dam debris out of the river. You can see all the rebar. This was 1916, and it was similar to Embry Dam. However, the rebar was square, and there was a lot of rebar in this dam. I don't think this dam was going anywhere anytime soon in terms of the dam itself failing. And then this is just a music video, or I should say music to our ears hearing this. Hopefully this will play. And the sound of the ram hoe tearing up the dam and the smell of the concrete dust is very pleasing when you're trying to get a dam removed. As I'm sure a lot of people on this call have been involved, can understand that. We also knew that there was going to be a crib dam behind Ashland Mill Dam. We had seen it at low flow, but we got a really good look at it with the dam coming completely out. these very old oak and pine structure, call them timber crib dams. There was one behind Embry Dam that dated to the 1850s. My assumption is this dam is probably mid 1800s, but there was even a dam here prior to that, late 1700s, early 1800s. But I think this one is probably an 1800s dam. Just a little bit more of the process of removing the dam from the river, working their way across and controlling the flow. We've had a really low flow period, except for one high water event after Helene. But other than that, it's been fairly easy working conditions for the contractors. Right towards the end of the removal, we wanted to make sure that at least 75 feet of the river had no dam whatsoever in it. And so we found a little bit of concrete, so we had them get that out. That's just a shot of the pile that we got out before they were taking away the Ramho equipment. Then one of the final things they did was build this river right bank stabilization wall, because the old mill building is not being used for milling anymore, but one of the warehouses there you see in the background is being used to make glue for a nearby corrugated box stock factory. So they needed to protect this bank. Those are 1 to 2 ton boulders, just to give you an idea of size. And those were several rows deep down to bedrock to protect the bank. And there's the end product of what that looks like. It's just been seeded with a riparian mix. And this not only will protect that bank, but it also helps reduce the width of the river back to its normal width, because when you have a dam, you have a wider river channel where the dam is artificially. So we want to get the river back to its normal width, so we'll have a better thawweg and the depth of water there for the fish to be able to swim upstream. So going forward, we've got 10 years of monitoring planned. We've already started some early post-removal electrofishing with some of the students at Randolph-Macon. We don't expect to find the target fish, other than eels at this point. And so it's just a practice of getting some experience for these students and just showing that these fish aren't there yet, because it's fall. And then there's some strict criteria that the Davy has to show in order to get those credits released. And Randolph-Macon is going to continue to monitor stream changes, both physical and water quality changes. And we're just all looking forward to spring of 2025 to start monitoring for the adult spawning and migrating shad and herring. And then hopefully I can do an update next year in the fall meeting and talk about all the herring and alewife and shad that we find upstream. And there's that's what it looks like now. The mill building is off to the left there. We've had really drought conditions, so the water levels are really low. We're going to need some rain to resort things back to the way they should be. We'll see what the real depths are through the river channel here. Hopefully that'll get back to what it was pre-removal, which we expected to. And there's a really cool, with the webcam, there's a really cool time-lapse feature. And so you can watch the whole project happen in about 5 minutes. You can get a chance to check that out. And so with that, I'll take any questions.
Great, thanks, Alan. Yeah, no, I appreciate you sharing this update. I had a question, and then I will take a stab at answering Jason Didden's question. But I was wondering if you could tell me, did the mitigation plan or the monitoring plan specify how they were going to document passage upstream of the dam? Is it eDNA? Is it electrofishing? Is it kind of whatever method can show positive detection? Just curious as to, and I guess assuming that Davy will be responsible to demonstrate the success of the project, what methods are you guys looking at? Are you looking at monitoring at that small dam that you said was overtopped under higher flows? Things like that. What's the plan there to document success?
It's a combination. So the eDNA is being done just in case when we're sampling upstream, if the run size isn't large enough and we're not able to find fish by electrofishing, the eDNA is kind of a backup plan. And just to also just further that research to match those things up. So we'll be we did not, Davy does not have to show how far upriver the fish go. That was going to be part of the 2009 plan. We were working on a way to have, X number of miles of stream used as sort of a biological restoration, and not just linear feet of stream restored. But in this case, they're not required to show distance upstream. But yes, we'll be sampling, at the upper end of the impoundment. We'll sample up at that dam upstream, and I'm definitely interested in sampling above that dam. We actually have a boat ramp there, and so we can put in a small John boat and sample above that little 3-foot dam, and hopefully find fish. So yes, so and as far as Davy being responsible, yes, they need to be able to get that information, and like I said, our data's public information, so we're more than happy to share that data when we start to get those results. But yes, it's not a distance thing. It's just showing the passage. But they do have to be documented at least 2 years out of the life of the 10-year monitoring.
But they're essentially using your data
yes.
as their performance to document their performance. Interesting. Jason did ask sort of a more just conceptual question about, what are the credits offsetting? How are they used? So, Jason, this is, and for those who aren't aware of kind of the mitigation banking universe, essentially, when people are impacting streams, it could be building a bridge, it could be, putting bank stabilization, things that are impacting, public waters. Typically, the Army Corps and the state, or they can require compensatory mitigation for those impacts to public waters. And one of the ways that permittees fulfill their compensatory mitigation requirement is through mitigation banks, which is essentially a way of bundling up typically a lot of smaller impacts and putting those mitigation needs towards a larger project, in this case, dam removal. So that's essentially the demand is anything sort of in the localized area. There's a defined service area for credits. Anything within that area that impacts waters that's assessed mitigation could end up having to essentially purchase credits from that dam for the restoration work that they've done. So it's a whole process. It's moderated through each state, each Army Corps district state has a interagency review team that reviews these proposals and specifies the conditions for mitigation banks, including performance standards and things like that. So that's a whole topic in and of itself, but that's essentially what drove the need here. And it's interesting to see. It hasn't been, my understanding, at least on the East Coast, that mitigation banking to remove dams hasn't been done extensively, but it has been done in a few cases. So. I don't know, Alan, if you had anything you wanted to add to that. There was some questions.
This one it's the first of its kind in Virginia. So there's been some TNC has done some in lieu fee dam removals. They're nonprofit, but this is the first one of its kind where it's private funding invested, and it's for future development projects that are going to be required to do mitigation. If this would have come out for Newport News, it would have been a permittee responsible mitigation. This is a mitigation bank. So like you were describing, this is for projects within the York watershed. That's the service area, especially since they're migratory fish moving up and down the whole watershed. And it's for mitigation credits that can be sold as stream impacts occur in the future. And there's obviously planned development. I don't know what all the planned development is throughout the whole entire watershed, but obviously Davy knows that there will be development in the watershed, and so they have their eye set on some potential projects. They'll need to buy credits. So you get your ecological uplift up front, and then those credits can be purchased down the road.
Right. Ben Everline asked if you had any idea of the cost of demolition and construction on the project, and then was curious if there was a link to the monitoring plan. So I don't know if you have that information share?
Not an online monitoring plan that we have, other than, we're going to be, spring sampling again. This time we'll add upstream. We don't have Randolph-Macon and I, we don't have something to go to see the exact monitoring plans. Weekly electrofishing, and then the eDNA analysis will be weekly water collections. They're processed right at Dr. Stephanie Koster, right there. Randolph-Macon's doing the eDNA analyses. And what was the other part of your question? Oh, the cost. Yeah, well, I know a little bit about the cost of the demolition. It's kind of what you'd expect. It's not really, the total cost of demolition and bank stabilization work is something that Davey wasn't putting out there for public consumption, but it's kind of what you'd expect. It wasn't a ridiculous amount of money to do the dam removal. If I was budgeting this dam removal, might have been a little bit more than I would have thought it would take, but nothing outlandish. Because it was really just basically what you saw. It was the physical demolition, no explosions used or anything like that. We're literally a 9-iron shot from Route 1, and typical costs. I can tell you that the stones, the giant boulders for the rock wall, they're like $100 a ton, and some of those are 2 tons. To give you an idea of how much that stabilization wall cost. So there's a pretty good chunk of money invested, but then those credits can be sold for quite a bit of money also.
Right. Ben, I guess for your reference, I know if you're interested in looking at costs across projects, I know it was something that we worked on in the restoration showcase in the 2023 River Herring Habitat Conservation Plan. We've got a couple of fish passage related projects for river herring detailed in the back there. And I know at least one, if not several of them, had some dollar amounts associated with them. But yeah, in this case, I could see, this is essentially a for-profit dam removal. I'm not sure that you're going to be able to necessarily get that information, since it was done by a private company. And then to add to the question around the monitoring plan, I mean, I'm sure at least somewhere in the banking instrument, which would be available through the Army Corps' RIBITS, RIBITS website, there should be I would imagine there's a publicly available plan for this removal, and it may note, like those success criteria, but whether or not it goes into the detail of the actual monitoring plan, it doesn't sound like it does. But
yeah, the MBI is public information, and it's a pretty large document. It's like over 50 megabytes. But yeah, I think if there's a way for me to share it with you, Jonathan, then if you could share it. But I think the RIBITS, I think it's available through that. And yeah, I'm not sure how the monitoring plan is pretty much what I explained. It's not anything elaborate. It's literally, finding the fish species. Now the mussel plan, that'll be different. That'll be, Davey that'll be contracted to get somebody to, they contracted somebody to do the pre-removal mussel work. And of course, our malacologist, Brian Watson, was, commenting on the whole thing, but, we won't be doing the mussel research. It'll be, contracted to a private firm to do the mussel work. And that'll be several years down the road, because it'll take a while before you have a chance of seeing some of those mussels return.
Okay, great. And just wanted to note, Alan, Steve Gephardt and Dave O'Brien both commended you in the chats for a great project, seeing it through to reality. So.
Yep, we're just they've heard about this project a long time. We're happy that it's finally done.
Yeah, great. Thanks for sharing that update with us. If folks have questions, feel free to follow up with us after the forum. We can put you in touch with Alan and get you any information you may need. Or if you needed a link to the River Herring Habitat Conservation Plan, can certainly provide that as well. I'm happy to have that get some more readership. We are 8 minutes away from the end of the meeting, so am glad, I guess we went a little short earlier on, so we had time for all the discussion and questions. And really just wanted to open the floor to general questions, updates, discussions. Raise your hand, put it in the questions box. We will do our best to get to it in the next couple of minutes. And it's just sort of a, just to prime the discussion. One thing, I was up in New England recently, and Alan also mentioned it as well. One thing that came to mind is throughout much of the, at least mid-Atlantic and New England range of river herring, we are in a pretty serious drought here during a time period when the juveniles be out migrating, or at least in New England, from some of those rearing ponds. I didn't know if folks had any thoughts or concerns, things that they've seen done on the ground to try and help out migration, or if we're just all crossing our fingers for the next late tropical system to help those out migrating fish. But certainly something. I see Kevin had his hand raised, so I imagine that's a concern in Connecticut. Please, Kevin, feel free to chime in on that.
Is my mic working this time?
Yes. Yeah, great.
Sweet. All right, thank you. Appreciate it. So we've got that going on here. We're getting very used to dealing with drought in Connecticut, though. So kind of some of the things that I would recommend, and I know the guys up in Maine that run the commercial runs do the same thing. It's kind of counter to what you'd think to do, but when we're dealing with such small runs here, it's kind of necessary. Walk the stream below those dams or spillways or whatever it is that those fish are caught in, and clear anything that's going to catch leaves. I say that because once that spills, those fish are literally sitting at the lip of those dams or fishways, and when they dump, all those leaves dump with them. And what we've actually seen in the past is you'll get a massive fish kill where all the leaves will pile up in a jumble of sticks, and the fish just pile on top of each other, and you'll come in the next morning and there'll sometimes be thousands of dead fish, if not more, where they just kind of crushed each other. So what I did was, we've had leaf drop here. So the places that we have fish trapped right now, which luckily we had a lot of rain coming into this drought. So in June and July, we had a lot of fish leave, the most I've ever seen leave since I started here in 2018. So that was really good to see. Looks like it was very productive. Yale University does a assessment at many of these. They basically do a Young of the Year index for us, many of these sites, and we had near record numbers at many of the sites, which was awesome. And many of those fish did leave early. There's still a ton of fish out there. They were out sampling, I guess it's been 2 weeks now, maybe 3 weeks. But the fish that they sent me pictures of were deep bodied, looked much better than years past when fish have gotten trapped. So I think the bulk of our fish did get out because the fish that are trapped in there look healthy. So we've had fish leaving as late as the first of the year, in the new year. So fish will leave in the middle of winter here if they're trapped. I'm hoping that doesn't happen this year, but if it does, at least the fish that are in there have a lot of mass to them. I'm not sure what others are seeing. I was talking to some of the people up in Maine, and they were having similar concerns at some of their runs, and they're doing the same thing. One of the guys went as far as to take a leaf blower down the middle of the dry stream bed, so we're not going that far here. We're just trying to make it a little bit easier. It's it's the same thing. Normally we wouldn't be notching a beaver dam, but we have so few fish now that in the spring, if the fish are piled up below a beaver dam, I'll notch the beaver dam to let the fish get through that night. The beavers rebuild it, the fish get upstream. I'm doing the same thing for out migrants this year. We have a lot of beavers holding water. I'm not touching that. If the fish are there, I'll make a really small gap in there. I don't want to dewater, what the beavers have built up either. So, use judgment here. But I think most people, at least in New England, are going to find that there's quite a few fish pooled up. That's kind of what we do here.
Thanks. Yeah, that was a great rundown, and I'm glad to hear that you guys had a good early out migration, and maybe that those fish got the memo that it was going to be a dry fall. Anybody else want to share observations from the field or updates or questions?
I'm going to add one more thing, Jano.
Yeah, go ahead.
Sorry,
Yeah.
that's really interesting. So I went back because we had a lot of concerns after many years of drought off and on here. And Bride Lake, which is kind of our bread and butter, it's the one of our runs that we have the most data behind. Oddly enough, we had these really bad droughts in 15, 16, 17. Our best returns were 3 and 4 years after those droughts. So you'd expect that, these runs didn't spill until almost the middle of winter. We thought for sure that we would have horrible returns 3 and 4 years later, and we did age those fish that came back, and our average was like 3.2 years old. So it was fish from those drought years. I'm wondering if there is something to those fish that do get out early versus the fish that do get out late on years that maybe these fish get out late. There's less predators when they dump out in the middle of wintertime. I don't know, but I found that really bizarre because we expected to see the complete opposite. We thought drought's bad. Oddly enough, at least where we're monitoring, it's obviously site specific, but just don't completely panic because these fish have evolved to deal with a lot. So just, try and get them out safely.
Yeah, great thoughts. And a little bit of hope, I guess. I was, a little worried. I saw the wildfire reports up in Western Massachusetts, and I was like, oh, that seems, it's pretty dry up there. So I'm glad to hear that maybe, it's not as concerning as I may have feared, at least in one case. Okay, we have 1 minute left. Any last minute comments or questions? Otherwise, we can move to adjourn. And really appreciate you guys helping to cap out the 10th year of the River Herring Forum. We'll look forward to 10 more years. And if you've got any presentations or updates to share in future meetings, please reach out to James and myself. As always, we'll put out the call for presentations for the spring meeting. And I guess we'll let you guys know when we schedule that spring meeting and put out the call for presentations, a month or two ahead of that meeting. So thanks again to our presenters and all of our attendees. Really appreciate you all participating today, and we look forward to meeting you in the 11th year of the forum in next spring. So thanks, everyone. James, do you have anything to add to close this out? Please go ahead. Maybe James has already left. All right, everyone. Well, we'll see you next time. Thanks for calling in. We'll end it here. Thanks.
Thanks, Jonathan.